Alright, I'm Gordon Marsh, and today we're going to talk about the original hydrogen machine we built with the first passive dual modulating regulator. We'll go over these functions because they're going to be almost identical in the larger machine, which is currently under construction here. This thing is designed to produce 10 liters per minute of high pressure hydrogen at 5,000 psi and be able to pressurize a fuel cell car at 10,000 psi. So we'll show you how we're going to do that in just a minute. First, let's go over the older machine. I'm going to sit down because I don't have a cameraman today, and the camera's just going to follow wherever my face is. So I'll sit down so I can hear the machine better. Here we use distilled water. Here's the water inlet. On the outside we have pressure gauges and valves. Hook up for solar power, the relief, and our AC supply coming in here. We've got an on-off switch and a fuse in there. In the back we have our exhaust vents. We have our cooling vent on the inside and two lift handles and an oxygen outlet. Back cover here. We have a selector switch for either AC or for solar. We'll have the same thing on the bigger machine, just a bigger switch. Here we've got a volt amp meter. We can adjust the voltage of the amps if need be. We can turn off the PEM for testing if we need to. Water pump switch, an alarm for low water, and a silence button for that alarm. Inside we've got some timers, delay timers. We've got a water supply. At the bottom you see a pump, the battery for that helps the solar regulator. We got the water oxygen separator. We have the hydrogen oxygen separator over here. This thing also acts as a float valve to relieve or return the excess bleed through water from the PEM back to the water supply. And we have the PEM down there in the corner next to the vent. We have a power converter, a buck boost power converter to supply 12 volts DC to the control bus, which supplies all of the controls, relays, etc. We have control relays down here, circuit breakers, and we have a power relay over by the PEM, and the our passive dual modulating regulator is up here behind the water supply. I don't think you can see it right in there. So that covers the original machine. There's several of these that have been made and running. Now we'll talk about the other machine for a moment. Okay. So this machine is designed to make enough fuel for the Toyota hydrogen fuel cell car in about 4.5 days, and not use any additional energy to compress the gas or to transfer and pressurize the Toyota at 10,000 psi. So we have here, on this computer tower rack, we have our AC power supply. We have basically have these panels in the front connected to it, which will have all the controls like the smaller machine did. Hopefully we'll put a LCD screen in that one. At the bottom right here we have the pressure booster. This one we're using for the water. I'll take a close up of this one. This one can go to 15,000 psi. So we just run it built to run on compressed air, but we're going to run it on compressed hydrogen. And this will be the water inlet and the water outlet. We have to pressurize the water to whatever the maximum pressure in the tank is going to be. So if we want to make 5,000 psi hydrogen, we have to be able to replace the water at 5,000 psi. So that's what we're using this little beauty for. And we're not using any energy to run it because we're capturing the stored energy in the compressed oxygen to run this. We'll have another one like this, similar to this, for pressurizing the hydrogen into the Toyota. This one here is only about $500, and one large enough to do the hydrogen for the cars is about $1,500. So relatively inexpensive for what we're accomplishing. So anyway, that's the gas boosters that we're talking about in the text I sent. This whole thing will be covered with all the equipment that we need to run everything, electronics and plumbing. We're also using a particle filter for the makeup water supply, because we don't want, if any dirt gets in there, it's going to ruin the PM. We also have a resin deionizing filter. these will both be in line between the outside water supply and the pump pressurizing the water going in. Then we have, see if we can move this closer. I'm going to sit down again so the camera can follow me. Okay. So on the bottom here, we have a 10 liter per minute PEM. You see the power cables are coming up and they're going through the head of this drum. We're using this drum and this lid to simulate a high pressure vessel. We're doing that because we have to get the sizing right before we order a very expensive vessel, and it doesn't work. So we're assembling it in this to see how that works. The system's designed to use low pressure equipment inside a high pressure vessel, because a high pressure PM like this that would be rated for, let's say, 5,000 psi would cost hundreds of thousands of dollars. This PM here, 10 liters per minute, only the first one only costs us $5,000, and the price goes down, I think, about $1,500 when you buy them in bulk. So this whole assembly here that's on this lid is going to sit down inside the pressure vessel over there. All of the fittings, all of the plumbing fittings that are necessary, they'll all connect to the head. So is the electrical connections. Inside here, it's going to be difficult to try to use float switches in high pressure because the floats will collapse. So instead, we're going to use these little ultrasonic level sensors, and they will be placed on, well, this is the water tank anyway, supplying PM. So these two sensors will be placed on a tank somewhere, and they'll detect high and low levels. When it gets to a low level, the pumps will come on and bring it up to the upper level and then shut off. It's going to be a switching, a latching relay type situation. The regulator also will be mounted down in the bottom, just underneath this top platform. And the hydrogen gas will be coming out of the hydrogen port of the PEM and just pressurize the whole vessel that this is in. That will give the inside of things like this water tank and the PEM and the regulator, the pressure on the inside of them will be virtually the same as the outside pressure, so there's almost nil pressure differential, and that allows us to use these inexpensive low pressure equipment in a high pressure system, such as this plastic tubing here. We got the little simple connectors. I'll get a close up of those. So these little simple connectors, you just push the tubing in, and if you want to remove the tubing, you pull the sleeve back, tubing comes out. That's so much easier than the stainless steel tubing we're using in the small machine. In fact, the big machine, it's much easier to assemble than the smaller machines. We could assemble probably 3 of the big machines in the time it takes us to assemble 1 of the small machines because of all the complicated high pressure stainless steel tubing. And this eliminates that, and big time and money saver. So, as I mentioned, we have the water tank. Water is going to be supplied by the tank in the back here. So we get a picture of that. So this is where the water starts out. This is a 15-gallon tank, and this is going to supply both the particle filter and the resin filter, and then it's going to go through the booster, the water booster, and into the vessel through the head. And as water gets consumed in there, it will be replaced with this water. Also, when the water returns, let me explain that first. So, when we're running this, the PEM, there is a little bit of a water bleed through on the hydrogen side. So that's going to come out, and it's actually going to fill the bottom of the vessel. And we're going to put a float valve in it so that when it reaches about nearly the top, the float valve will open and return that hydrogenated water back to the outside water supply. And now with that, we have to make sure that we get the dissolved hydrogen out of the water before we send it back into the tank. Otherwise, we'll have hydrogen in our oxygen supply. And we do that by using ordinary fish tank bubblers. So we'll put the fish tank bubblers in with little air pumps. These will be sitting on the bottom. These will aerate this water. As the bubbles come up, it pulls the hydrogen out of the water, and we can strip all the hydrogen out of the water before we have to send the water back into the tank. We use this on the smaller system, and it works very well. So I'm sure it's going to work well on this larger system. So back to the water supply. Well, water will come in here from the outside. It'll go out the bottom of this tank into the bottom, the water inlet of the PEM. And then when power is supplied, the hydrogen will come out the other side right here. Oxygen will go back. Oxygen and water will go back into the water tank where the water and oxygen are separated. The oxygen then will go to the regulator, and then whatever oxygen it needs to keep the back pressure it'll keep, and the excess oxygen will go out of the tank into the high pressure oxygen storage tank, which will be later used to run the pumps. That's pretty much it. It's pretty simple. There's not a lot to it. It's actually more simple than the small machine. But we're going to actually run this one with the plastic drum. We know we won't get the pressure with it, but it will just make sure that all the systems are working right at that lower reduced pressure for that drum. We'll still be able to take that gas with the gas booster and bring it up to 10,000 psi, even though we only have the low pressure that's in this drum. We can still do that, but not as efficiently as a high pressure vessel. So that's where we're at. Once we run this, we'll make sure that all our sizing is right. Then we'll order the high pressure vessel, and we'll start to put this equipment in that vessel. That's it for now. Thanks.